Can you imagine what it must be like to want to stop doing something but not be able to do it? Hey guys, welcome back to my channel. If you are new here, I'm Rhea the Science Girl, here to talk to you about all things science. Before we get started, don't forget to hit that like and subscribe button down below because it does help me out quite a lot. Without further ado, let's get right into today's topic. Today we're going to be talking about addictions. Addictions have always fascinated me, but let's start by talking about what addictions really are and clearing up a common misconception about them. Addictions begin as a learned behavior that, after being frequently repeated, change the neurochemistry of our brain, especially in the region associated with decision making, literally leaving us less in control of this behavior. Now, the common stigma around addictions is that they are a result of poor self-control and are personal behavioral choices that one could control if he actually wanted to. But I have personally never met an addict who actually wanted to be an addict. So, is it really a choice? According to my $300 psychology textbook, there are a few different ways that behaviors can be learned. The three main ways are observational learning, which is basically like monkey see, monkey do. You watch someone engage in a behavior and then you engage in that behavior. The next one is classical learning. I am sure many of us are familiar with Pavlov and his salivating dogs.
In his experiment, Pavlov referred to the dog food as an unconditioned stimulus because it had an unlearned effect on the dogs. It triggered an unconditioned biological response in the dogs that occurred naturally, like salivation. He then introduced a metronome to the environment as a neutral stimulus because it did not elicit any meaningful response from the dogs at first. Once the metronome was repeatedly paired with food, the dogs learned to connect the two stimuli. The metronome then becomes a conditioned stimulus that begins to elicit a response such as salivation, which is then a conditioned response.
So that is classical learning. And the last one is operant learning, where the likelihood of the behavior repeating is dependent on the outcome of that behavior. And that is where reinforcements and punishments come in. Reinforcements are used to increase behavior and punishments are used to decrease behavior. Addictions are a direct result of extreme reinforcement. So after engaging in the behavior a few times and receiving this extreme reinforcement, the behavior becomes learned. And it continues to occur even after the reinforcement becomes less pleasurable or stops becoming pleasurable at all. Studies have shown that rats, after being exposed to high sugary and fatty foods, not only ignored their regular foods, but also continued to consume the unhealthy foods even when they were punished for it by being repeatedly shocked. It's almost as if they couldn't help themselves. Can you imagine what it must be like to want to stop doing something but not be able to do it? To not be in control of your actions and behaviors? We briefly talked about how addictions can actually change the neurochemistry of our brain. Now, I'm sure we're all familiar with the fact that addictive behavior increases dopamine in our brain's reward region that is located in the limbic system. Dopamine is often referred to as the reward and pleasure neurotransmitter. It is usually released when we come across an experience that is crucial to our survival. For instance, dopamine is released when we eat or procreate. Its release signals the brain to take note of the behavior and remember it for future reference. We are then more likely to repeat these activities that increase dopamine levels in our brain, which plays a large role in addictions. But where's the line between being able to occasionally engage in these behaviors and feeling the compulsive need to engage in these behaviors. Turns out that the frequently repeated engagement in these addictive behaviors produces sharp and short-lived spikes in dopamine, which eventually leads to a loss of dopamine D2 receptors in our brain. This reduction in the levels of dopamine D2 receptors affects the functions of the frontal area of our brain, the area that is directly related to decision making and allows us to control strong urges. This is why an addicted person could be more vulnerable to impulsively engage in these behaviors. I have personally always found it fascinating how addictions can be genetic, but it all makes sense now. Due to the altered neurochemistry of an addict's brain, the generations that come after them could be genetically predisposed to the lack of dopamine D2 receptors in their brains. This would lead to the same cycle of not being able to draw the line between occasionally engaging in these addictive behaviors versus feeling the compulsive need to engage in these behaviors. Addictions have been a large part of society, from the Opium War of 1839 to the cocaine crisis of the 1980s. The temptation to engage in addictive behaviors is all around us, and the best we can do is to understand the permanent effects that these behaviors can have on ourselves and on the generations to come. I will be doing a series about how the brain reacts to different addictive substances. So if that's something that interests you, please stay tuned for the next couple of videos. And until next time, Rhea the Science Girl, out.